CATIA V5, Shape Sculptor. We're going to start with the editing toolbars. So the first one will be Decimate. As we can see, the Decimate will reduce the number of triangles of a mesh. So let's get started. I have over here the Blender Monkey subdivision. As you can see, this is quite heavy. So the mesh has a lot of triangles. If I will start the Decimate, we're going to see that we have two options. So we have the chordal deviation and we also have the edge length. Now, depending on the output, the desired output, you can either choose for a chordal deviation if you want to preserve the shape of the model, especially in areas with a high curvature. And this is why I decided to use the Blender Monkey, because we're going to have some of those areas over here. And we can also go by edge length, and that will also decimate the model, but will keep the length of the edge within the same uniform mesh. So I already have decimated the model over here. So we have the edge length taken to 10% and also the chordal deviation over here. So these are those two meshes. As we can see for the first one, I have set the chordal deviation to the default mesh color and the edge length decimate to yellow in this case. Now with those two overlapped over here is quite harder to see exactly what happens. But if you're gonna go and only show the first one, we're gonna see that the triangles over here on the, let's say on the head of the monkey, will be higher than in other regions. For example, over here on the monkey ear. But using the edge length, those will keep the same size. Now for the 10%, it is a little bit harder to see, but I will enable the 2%. And as we can see, there are some variations in the shape. So if I will just show the edge length, we're gonna see how the monkey will look like here. We see that there are no curvatures being preserved in comparison to this one. So this one is quite decent, even though it's only to 2%. We see that the overall shape of the monkey subdivision is still over there. So this is the original mesh, and this is the one taken to 2%. To better highlight those deviations, I will go with import design and I will do a sectioning, so dynamic sectioning on the X and Y plane. And if I will move this over here, we're gonna see the deviation between those. So we have the 2% deviation over here, and we have the edge length where we see that the mesh has been joined over here. So if I will jump to wireframe, we're going to see those triangles that will define that shape. Within the decimate parameters, we can also specify the number of triangles, and I have over here the 500 triangle version. So we're going to see that we have a total of 500 triangles over here. And we also have the same for this one, which maintains some of the curvature, but in some areas that has been lost since the number of triangles is so low. So keep in mind that I will jump back to Shape Sculptor, go to Decimate. You can either go for a target percent, so let's say that you only want to go to 50%. But before you do the decimate, I highly recommend that you're gonna copy the original mesh, because this will not have an, let's say an undo. You can reverse the last action over here, but it won't be editable. Therefore, it is best to copy this, have it pasted again, and afterwards subdivide this and see what are the results, if they are satisfying or not. For example, I want to take this to 5%. I can type in over here 5. We're going to see that the triangle count will be automatically calculated over here. So we have the default, the starting point in this case, and this will result in a mesh with 3148 triangles. So I can click apply. This will be the subdivided mesh. I'm going to hide the original one. But once you clicked it over here, okay, you have the possibility to go back, but you no longer have that decimate as an editable feature. So that is lost. This is why it's important to always create some copies so that you can make sure that the mesh will be decimated as intended. Keep in mind that you can also directly specify the triangle count. For example, if I want to decimate this monkey head only to 25 triangles, I can do that, but the mesh will be heavily deformed. So I can click apply, and we're going to see that this will be the decimated mesh in this case. So as you can see, nothing from the original shape, let's say, is preserved with such a low count. But now if I want to increase the triangle count to 50, I can click apply. We're going to see that it won't work. If you press cancel, so if you don't click OK, you have the possibility to have this restored. And if I will go, for example, for edge length, and I can type in over here that I want to define this by 150 triangles, you're going to see that the mesh will again look like this. So nothing like the original mesh. So keep this in mind when you are trying to decimate elements over here. It is the same workflow within Blender. So if you're familiar with other softwares, for example, over here in Blender, we have a quad mesh. As you can see, all those vertices will be connected with polygons. So we're going to have 4 edges in comparison to CATIA, which uses a triangulated mesh. We can go over here within the modifier, add a modifier. We can type in Decimate, so it will be the same naming over here as well. And we see that we have 3 methods. So the first one is collapse, that uses edge collapsing, unsubdivide, and there's also the planar. So we have the possibility to change this ratio, and this will subdivide. As you can see within Blender, you can do this in real time. So you're going to see how that mesh will change. You can also enable the triangulate, and this will create the mesh with triangles, just like CATIA sees that. And overall, the functionality is the same, but the collapse will have those options. We see the face count over here listed, and as we increase the slider, that will automatically update. The same within a statistic view. And we have the other methods, which is unsubdivide. Over here, we just have the iteration slider. And we're going to see that Blender can take this all the way down to 310 faces with this one. And as you can see, this will still maintain the shape of that monkey. If I'm going to slightly increase that even more, we're going to see that this will be the lowest value. And we also have the planar option over here. Over here we have an angle limit. And again, we see that this taken all the way to 400 faces will look like this. And I can take this even lower. For example, face count, as you can see over here, 198. And the mesh will look like this. But keep in mind that those will be faces. The actual triangle number will be higher over here, as you can see. So also for the collapse, if I can take this all the way, for example, over here, let's type in 0.01. We're going to have the same odd subdivision that we have in CATIA, but something like 0.01 with a total face count of 155 will overall maintain that shape. So if you're gonna take a look at this model, you can resemble the monkey mesh from Blender. While in CATIA, those decimate algorithms will always heavily deform it even more. Yeah, so this was Decimate in CATIA v5. This is a great tool, but overall I think that other solutions such as Blender have this a little bit better implemented. So I will position a similar video over here at the bottom. I will add the Shape Sculptor playlist to the top, and I will also add a subscribe button over here. So that's it. Thanks for watching.